Hi, everybody. I wanted to welcome you back to our online learning for today. You probably just watched the video that I had linked in our lesson for today on how to make a hot air balloon at home. Some people call them hot air balloons, like homemade hot air balloons. Some people call them sky lanterns. Basically, they're the same kind of thing where you need some kind of heat source and then you have something that looks like a balloon shape object. So if you wanted to try to make one at home, please make sure that you definitely ask a parent to help you. Please do not make one by yourself or burn down your living room in the process of making one. So make sure that you talk to an adult and see if it's something that they are okay with you making at home. So I wanted to show you this really quick 2 slides. One of the reasons why I wanted you to watch how to make a hot air balloon is because hot air balloons actually tell us a lot about air. And so I wanted to show you this slide really quickly. This on the right hand side is a hot air balloon. And in the hot air balloon, a hot air balloon has no engine, nothing's pulling it into the air, it doesn't have wings. So if you think about it, we know that balloons fly in the air. And the question is, how come they go up in the air? We're just used to seeing them fly in the air all the time because when we were younger, we had birthdays maybe and had some balloons at our birthday. We're just used to seeing air, balloons filled with air flying all the time. But how is it possible that a hot air balloon needs down here this hot heat source and then the balloon just magically flies in the air? Well, there's a couple of things. The first thing is this heat source down here heats up the air, and the balloon has to be narrow at the bottom usually so that the air doesn't float away, the heat doesn't escape. You want that heat going right into the balloon, filling up the entire balloon. And most hot air balloons in real life take like 6 to 12 hours to heat up because I have been to a hot air balloon festival and they were blowing up the hot air balloons the night before. It takes that long. And so you want the air to heat up. And when the air heats up, all of these dots that you see on the screen represent air molecules. And so those are air particles that are in the air. And what do we know about air when it's hot and when it's cold? Well, we know what we've learned about water when it's hot and when it's cold. So I'm going to look over here on this left-hand side of the screen. When water is cold, the molecules are closer together and they're not moving as much. And so these short little vibrations show that they are moving, but they're not moving as quickly. They don't have as much energy because they're cold. And then over here, the molecules that are warmer are moving faster, they're spreading out, they have more energy. And so we learned that's true about the water cycle. This picture on the left for cold would represent condensation and clouds. And over here on the right, this red picture would represent evaporation or transpiration from plants. And so the same is true with air. It's the same as water. So when air is cold, the air molecules kind of clump closer together. And when the air molecules are warm, those molecules spread out. And so back to our hot air balloon picture, do you see inside the hot air balloon? These red molecules, they're not actually red in real life, but they represent warm air. And when air is warmed up, the molecules start moving faster and spreading out. And that's how the hot air balloon can actually inflate. But what makes the hot air balloon go up into the air? Well, if you look at the picture, the air that's on the outside of the hot air balloon is colder, and those molecules are closer together. So I wrote here in the screen, the molecules on the outside of the hot air balloon are closer together and they are more dense. That means that that air is packed more tightly with air molecules. Therefore, it is heavier. I know that seems weird that air would be heavier, but that air is actually heavier. Instead of calling it air heavier, we actually call it air pressure. But that air is actually heavier than the air that's on the inside, and that air is lighter. It is less dense. It's not as thick. It's not as compacted. It's less dense. That air is more spread out. And so what do we know about when things are heavier and things are lighter? If something is heavier, it's going to sink. If something's lighter, it's going to float. So if you look at this screen, these air molecules on the inside, they're less dense, they're lighter, and so the air inside is warmer, and that warmer air is going to want to go up, and that colder air is going to stay down closer to the earth, which means the hot air balloon can fly into the sky. And so this is something that has to work only if the weather outside is cold enough. This would not work on a hot summer day. If it was like 90 degrees outside, it's like July 4th, and you have a hot air balloon, it's going to be really hard to get that hot air balloon to fly high in the sky because the air outside the hot air balloon is going to be just about similarly warm to the air inside the balloon. And so the air inside the balloon isn't going to be able to float above the air that's on the ground. And so the best time to do a hot air balloon would be like in the springtime when it's really, really cold, or even in the nighttime sometimes, like in the evening when it's nice and crisp, or early in the morning, like 5 or 6 in the morning when that air is just that really crisp, cool air. That's the perfect time. So I wanted to show you one more picture as we wrap up our lesson today. Why hot air balloons rise. This is showing a Chinese lantern, or what we would call a sky lantern. If you've ever seen the Disney movie Tangled, the song At Last I've Seen the Light, they lift those sky lanterns up into the sky. That's exactly what a hot air balloon does. So again, the blue molecules represent cold air. And so look in this first picture. You have cold air inside of the lantern and outside when you're setting up your lantern. And then you're going to set a heat source. You're going to give it some thermal energy, and those molecules are going to receive heat and receive energy. And then in this picture, they're going to start spreading apart. Some of that cold air is going to sink down because cold air is more dense, it's more tightly packed, and it's going to sink down and go out. But the warm air is going to go up and start spreading out and fill that whole hot air balloon, or that Chinese lantern. And then you can see here, look how less dense the inside of the lantern is versus the outside of the lantern. And that means if it's less dense, it's lighter, it has less pressure, and it's going to start floating up above. So as the air particles outside the balloon are inside the balloon are heated, they spread out, and this makes the balloon less dense, which makes it float upwards because it is going to be not as heavy as the air that is on the ground. So I wanted to show you these pictures so that you can kind of understand how a hot air balloon works. Later in the week, we're going to talk a little bit more about air pressure, a little bit more about air density, what dense means, more dense and less dense. You can think of the word dense like how heavy, how packed tightly it is, because we're going to study that a little bit this week, and that's going to help us understand weather. So our next standard of learning is not the water cycle anymore. We are going to learn how the water cycle plays into weather, but we're going to learn about how weather happens. How come we have different weather all the time, especially in Missouri? One day it's 80 degrees, and the next day it's really cold and it's raining, and then we get sleet in the middle of the springtime. It just seems like there's crazy weather going on all around us, and that has to do sometimes with this idea of air being more dense or less dense, and some air is warmer and some air is colder, and that's going to help us understand weather. So you don't have anything to do today, you don't have any assignments, but I would like you to rewatch this video. If you didn't understand part of this video, go ahead and rewatch it. If you understood this video and you want to try to make a hot air balloon at home, I would love to see a video. Otherwise, you don't have any assignments for me to do today. I just wanted you to watch these videos so that you understand how to make a hot air balloon at home, or a Chinese lantern at home. I hope you guys have a great day, and I will see you guys in the next lesson.